What's that?
And then I get the log. We get to learn about log.
I don't think so. Mostly because I couldn't tell you what it is right now. Without having to look back. Maybe I can study it. Maybe before the next test, we'll have that. We'll do that for Power 50 and see if anybody can grasp logs, logarithms. It's got something to do with exponents and all that sort of stuff. Trigonometry, ladies and gentlemen, is basically the branch of math that deals with the relationship of the angles and sides of a triangle. Of the angles and sides of triangles. So you're talking about triangles, and they're all related in some sort of twisted fashion there, but we kind of look at, we have to look at it like this. And before we do that, we have to define some terms here. Now, it doesn't say right triangles. Does it say right triangles? But I do believe we talk about this right here. Draw this little triangle here, make it a right triangle. Let's say this is angle A, angle B, angle C. Wait, I gotta make sure I label this too. Okay. If you are looking at this from the perspective of angle A, that's the one we're going to look at first. You just have to be able to define these terms. Okay? You have to know that if you look at angle A and shoot directly across from it, this side here is called its opposite side. Okay? Okay. The long side, children, is always called the hypotenuse. Okay. Although, why is it? And the other side that's next to it that doesn't have, isn't the hypotenuse, is called its adjacent side. We won't talk about it from perspective of C, because then the opposite would be the hypotenuse and the same. But if we switch this around, let me give you the same triangle, looking the same way. Here's my right angle. If you're talking about angle B, notice it switches things up a little bit. The hypotenuse is still the same. It's not going to change. Okay, angle B, but the side opposite switches to this side over here. And this is the side adjacent. You got to get that because when you start talking about trigonometric functions, and I don't remember what they are, sine is like opposite over adjacent or something over hypotenuse or whatever over whatever. But yes, Nikki Cal.
Why isn't like the opposite and adjacent side just called like medium and large like it is on there?
Well, sometimes they're the same size.
Oh. Okay.
So to say bigger one, smaller one wouldn't work for every triangle. That's why they have to use opposite. Whereas opposite adjacent always does. Yes, say giant.
Where is the right triangle with the hypotenuse always be the same?
Yeah, hypotenuse is always the longest line. It's always the side. Hypotenuse is always opposite the right angle side. And we did this last year, I think. Did we talk something about it? We did about relationships or ratios or stuff like that. Yes.
So it's only for right triangles?
Right now we're just talking right triangles, yes. Let's take a look-see here. Now, here is kind of, and I might crash and burn on this. Let's say we have, children, a equilateral triangle. Can I change that? Let's do the best. Oh no. What just happened here? Where did my thing go? Is it here? Draw this. See if you can draw this with me. Draw a completely vertical line. Is that vertical? No, that's vertical. I'm just saying. I'm just asking, does it look vertical? Here, let me do this. There's my vertical line. See if this makes any sense to you. Is that vertical?
Yeah.
I am going to put two other lines here. I'm going to make myself a and equilateral, equilateral triangle. So here I am. I'm going to take this, swing it out over here. I'm going to take this one and side.
Oh, is the word stuff something?
Oh, here's the problem. Okay, let's pretend, if you will, that this is an equilateral triangle, shall we? Are you with me? Now let's, because I don't have any measurements there. What do we know about equilateral triangles? First of all, in an equilateral triangle, two things are true, Brandon. All sides are equal.
All angles are equal.
I really have to get straight here. All sides are equal and all angles are equal, and all angles have to be what in an equilateral triangle? Because in order for them to be all equal, and they have to be 180 degrees, John, it has to be 60 degrees. Now, just for fun, I'm going to take this triangle and I am going to split it in half. Well, no, just for fun. First, I'm gonna make each side a number, and I'm gonna make each side 2. Why did I pick 2? Because I want to. Because it's gonna help us right here. Now I am going to take a line and split this triangle exactly in half. And let's talk about what has just occurred here. And then I'm going to cover up. Can I cover up this one here? I only want to talk about this triangle here. I'm going to cover this one up. Nice work covering it up. So now I've got this triangle. You can tell me a bunch of different things. First of all, this is a 90-degree angle. It's a right triangle now because I split it down there, and that's going to be the height of that thing. How long is it from here to here? I cut it in half. It was 2, so now it is 1. Okay. And then, how long is this from here to here? No, it is not. That's speculation. You don't know. But we can figure it out using. So let's sit and put it in. Oh, and what is the degree of this angle? I took the 60-degree angle, cut it exactly in half. It is now 30-degree triangle. I have what's called in math a 30, 60, 90 triangle. One of the more popular triangles that they make in math. Okay, if I take this, put it in the Pythagorean theorem, I know this is the hypotenuse, so it's c squared. A squared is 1, and b squared, you don't know, so I get 1 plus b squared equals 4. If I subtract my 1, I subtract my 1. B squared equals 3, so b equals the, somebody, square root of 3. Not a pretty number, but it's a number nonetheless. Now, let me just tell you this, children. I'm going to get rid of this too because it doesn't help us. It was how long the side was. In any 30, 60, 90 triangle, this is your base triangle that you can use to find the relationship of any of the sides. In other words, this. Let's say I have a 30, 60, 90 triangle, but it's really big. Here it is. Okay, if I know that this is 20, it's all proportional. In other words, if this was 1, what's the relationship of 1 to 2? The hypotenuse is always double whatever the short side is. So if this is 20, I automatically know the hypotenuse of this thing is 40, and I automatically know that this side is going to be,
The square root is 30.
no, to go from 1 to the square root of 3, I multiply by the square root of 3. No, you can't do that. Okay? It is, if you take 20 times the square root of 3, you end up with 20 times the square root of 3. The square root of 20 times the square root of 3 is the square root of 60. Okay, but if this was just a regular normal 20, this is 20 times the square root of 3. So no matter what your 30-60 triangle is, you can always figure out the other two sides based on any number. If I had my little triangle here, and I knew that this was 80, this side is 80, the short side is always half of it, and this side is always the short side times the square root of 3. The number changes. Okay. Now, back to what we were talking about here. Let me see what they actually ask you here, because I so much want to. Oh, there it is right there. Here is what they're going to ask you. Can I take this and label this? Let me redraw this whole thing. Can I? My 30, 60, 90 triangle. 30, 60, 90. This is going to be angle A. Okay, with that being said, oh, where is it? What do I have numbers? 1, 2, and the square root of 3. With that being said, they're going to ask you this, and this is all leading towards the ratio with respect to angle A, the ratio of, you see, the first thing they ask you is the opposite side to the adjacent side. Opposite to adjacent. In other words, we're going to make a fraction that has the opposite side over the adjacent side. So here's my angle A. What side is opposite the angle A? 1. What side is adjacent to angle A? Here's angle A. What side's adjacent? I'll give you a clue. It's not the hypotenuse. It's the square root of 2. Okay. And that, ladies and gentlemen, oh wait. Why did I put the square root of 2? I don't know. Should be the square root of 3. Right?
Isn't the long side always the or
Well, if you're talking about angle A, 1 is always the opposite side. But see, if I was talking about the 60-degree angle, then it would be the opposite would be square root of 3 over 1. Okay? With respect to angle A. Oh, sure. Okay. What would be the ratio of the opposite to the hypotenuse? What's the opposite side? What's the hypotenuse? 2. So there's your relationship. It's the ratio of things. And that's all they're going to ask you for right now. They just want you to get used to that, calling things opposites adjacent, and getting used to the ratio thing. Because later on, that's where what sine, cosine, and all that sort of stuff is. That, unfortunately. That comes, wait, let me tell you. That doesn't come till, I don't know why they wait. Might not be till like 118, 119. Let me look, just so you don't. Yep, 118. Well, maybe we can just talk about it. Sure, let me just throw it at you so in case Lauren Daffenberg takes one of these tests right now. Here is the deal with sine, cosine, and tangents. Sine is always the opposite over hypotenuse. put it as sin, that's fine. We're just gonna abbreviate that. Cosine, I can put a D at the end of it, I guess. Spell it all over. Cosine is the flipped over of that, it's hypotenuse over opposite.
What's tan?
Oh wait, no, I'm sorry. It's adjacent over hypotenuse. I don't know what I'm doing. I don't do students very often. Did I say it was adjacent over hypotenuse? And tangent, ladies and gentlemen, is opposite over adjacent.
A bunch of those on there. Yeah.
In high school, you'll actually have to memorize.
Wait, is it sin? And what's like the abbreviation for cosine? Is that
I don't know if they do a cosine
COS.
abbreviation. Probably, yeah,
That's
that's
what was on the
COS.
back. That's what
On mine it was CON.
What's that?
On my map says it's
Yeah, I
CON.
didn't have this too.
CON? Cotangent? Cosine, that's not cosine, I know that. I don't know what COS is. Johnny?
So where does this come into play, like, in real life?
Your ACT test? I don't know. I can't tell you when any